Hello everyone, myself Dr. Deepak Malhotra, working as an assistant professor in the Department of Rehabilitation Sciences, Jamia Ahmedabad. Today I will be talking about science of Theraband in rehabilitation. I will be talking about some basic concepts that we use when we use Therabands in rehabilitation. Now, as you must have seen, elastic resistance that we use in our clinics and other sports settings. This is a Theraband. Okay, and it provides tensile strength, tensile resistance. Now, we must be using various types of modalities for giving resistance, like weight cuffs, like dumbbells, like pulley circuits. There are other modalities also, like sandbags and other friction devices. So we can use quite a number of modalities for giving resistance, but Therabands, they are unique. In terms of providing resistance, in specific manner, targeting specific muscles, how we can modify the angles at which we can train the muscles, how we can target a specific muscle, how we can target a movement. Because when we talk about training, if we can train the movement, we can automatically train the muscles which are required to do that movement, because our brain recognizes movement. So if you are training the movement, the muscles which are required for that movement are automatically trained. So some basic concepts about Theraband I would like to mention. As you all know, the elastic force is giving you the resistance. So when you talk about elastic resistance and other resistance devices, you will get similar benefits. The strength adaptations would be same. You can achieve similar strength with Therabands, with elastic resistance, as you would achieve with free weights or machines. So don't be confused that if you will use Therabands, you cannot develop your resistance, your strength maximally. You can develop your strength maximally. That is there with Therabands. You can do that. Now, when you talk about a Theraband, how much force does the band produce? So it depends upon the elastic coefficient. Three factors basically: the elastic coefficient, the cross-sectional area of the material, and change in length. Within a particular band, the elastic coefficient is constant. Okay, so that K is constant. Then you have the CSA, is the cross-sectional area. Cross-sectional area is the length into breadth into width. So that is also constant for a band. So you have an elastic coefficient and the CSA, the cross-sectional area, both of them are constant. So now we have delta L, which is change in length, because the formula is elastic force is equal to K into CSA into delta L. Now we have to manipulate this length to change the force of the band. So the percentage elongation of the band is given by, if this is the resting length and this is the final length. So final minus resting divided by resting length into 100. So that will give you the percentage elongation. More the percentage elongation, more would be the force produced by the band. Okay? So if you are elongating it by 25%, then the force would be less. If you will be elongating it by 100%, the force would be more. Similarly, if you go for 200% elongation, the force would be still more. So, for a band, for elastic resistance band, the force depends on the percentage elongation regardless of the resting length. So, it is the percentage which we have to take into consideration, not the resting length. So, if we stretch a 1 meter band to a 2 meter band or a half meter band to 1 meter band, in both these instances, you will get similar resistance. Okay? The force of the band would be similar. So that is one aspect. I need to mention another very important aspect for bands is that in muscle physiology we read about length tension relationship. As we may be knowing that as per the length tension relationship, the muscle produces maximal force in the middle range, and in the outer and inner range the force production decreases. That is there because at the middle range the muscle is at its optimal length and there is maximal cross bridge formation between the actin and myosin. At the inner range there is interdigitation and less number of cross bridge formation takes takes place. At the outer range, there is not much overlapping. That is why, again, there is less number of cross bridge formation. So, you get maximal force in the middle range. So, you have a bell-shaped curve. So, at the outer range and inner range, the force production of the muscle decreases, and the inner range, the force production is maximum. So, you have a bell-shaped curve. Now, you should have a resistance which should match this bell-shaped curve. With the bands also, this is there. You know, the bands, basically it depends on the force angle. When, say for example, I am talking about shoulder abduction. Shoulder abduction, when I am doing this angle, the angle between the force vector and the lever arm, it is 180 degrees. And the resistance torque is given by force into the lever arm, the moment arm into sine theta. Now the sine theta at this moment is 180 degrees. So the torque against abduction is 0 here. Okay. Now here, because there is not much force generation by abductors, the torque is also here 0. Here the abductors, they generate maximum force. And the sine theta is 90, sine 90 is 1. So the band is also giving maximum external resistance. And here, now as I move up, the angle of my shoulder is 180, but the angle, the force angle between the lever arm and the band is 0. Sine 0 is again 0. So the resistance against abduction is again 0. So there is a matching between the force producing capability of the muscle and the torque, the resisted torque provided by the band. So the strength utilization ratio, if you talk about, is good when you are talking about training with Therabands. Another aspect which I would like to mention, that the Therabands, they don't depend upon gravity. So when they are not relying on gravity, like your free weights, they rely on gravity. So you have to exercise only in the vertical direction to train a particular muscle, because the free weight will always move down. Because it does not rely on gravity, you can exercise from any direction. You can fix the band at any point with a particular object or a particular accessory, Theraband accessory, and then you can exercise. So that is why, because it is not relying on gravity, you can work out various functional movements. You can do training in various functional movements, because I think as per me, Theraband or elastic resistance is the best means of doing functional training by training the movement. One example would be, say, if I have to train this activity for my sports performance, so I can train the whole kinematic chain and the movement itself. So because the bands, they do not rely on gravity, they can be very beneficial in training of functional movements. And also because they don't have weight, the chances of subjects who are beginners, they will not be able to cheat in for the exercise, because if you have heavy weights, then in the beginning certain individuals can cheat by creating momentum. So in brief, I would like to say that Therabands, they add another dimension to your rehabilitation. When you will start using Therabands in your practice, you will feel the difference, because this is just the tip of the iceberg which I have mentioned here. There is such a vast area which you can explore in this field. When I talk about application of elastic resistance in rehabilitation and sports and fitness, you would wonder that sky's the limit. Thank you.